So in the previous session, we were looking at creating of calculation views. So we have created until calculation views of type dimension. So in today's session, we'll continue with the remaining session. Voice break. Bharat, is this okay now? So everyone, voice is okay now? Hello everyone. Mr. Bharat, is the voice quality okay?
Yes, sir. Okay, sir.
Okay. So okay, we'll continue the session. So let me expand the system. Bharat, please mute yourself. Expand content. So once we expand content, so once we expand the content, so let us go to the package. Let me go to ECC July 19. Let's expand the package ECC July 19. Expand the subpackage SD and MD master data. Expand the calculation views. So in here, the other day, we have created the calculation views of type start join. So let me just delete this and start creating again. Let me delete this view. Click yes. Right click on the package. Click new. Click on the calculation view. And let us provide the name. CV underscore actual underscore plan underscore copa underscore data underscore start join. And data category as cube and check the start join. So once we check and click finish. So once we click finish, so in here we would see so here you have semantics and here you see the start join. So at the start join, so first let us select the dimensions. Let us select these 3 dimensions and drag and drop these 3 dimensions, which is company code, customer, material. Drag and drop to the start join. So once we drag and drop to the start join, So once we drag and drop, so here in the details pane, so we would see all these three dimensions: company code, customer, and the material dimension. So now let us take, let's try to be slow. I think there is a network issue. So click on the projection, click on the projection, and click on the projection. Click on the projection and click on the projection. So first what I've done is I've clicked on the projection, click on the projection, rename as actual. Again click on the projection and projection, give it as plan. So in the actual projection, click on the plus icon, add objects, and provide the table name. Provide the table name as C1IDA. Provide the table name as C1IDA. And search for the table. Let us search for the table C1IDA from HANA user. Okay, I think few participants missed, so let me redo this again. I'll just try to do this again. Please see here what I've done here. So participants who have missed. So first click on the projection. So what is the first step here? First we need to drag and drop. All the calculation views from ECC July 19. Just select all the calculation views and drag and drop into the start join. So once we have done, the next step is click on the projection and click on the projection at the scenario pane. Right click on the projection 1 and click rename and provide the name actual. Click OK. So that is for the first one. Let us click on the other projection and click again. So here we see two projections. One is actual, the other one is the plan projection. So let us rename. Right click on the projection 1, click rename and give it as plan and click OK. So this is the first one and this is the second one. So now in the actual projection, let's click on the plus icon, which is add objects, and let us provide the table name CE1 IDA. So let us select this table. Let us select this table, CE1 IDA, HANA user, click OK. This is from the actual projection. At the plan, click on the plus icon again, add objects, CE2 IDA. From HANA user and click OK. So in the actual you have CE1, in the plan you have CE2. So once completed this, so the next thing that we have to do over here is we need to combine both actual and plan data. So in order to combine, click on the union and click on the union on the free space. So link union with projection. So just like how I have done calculation views of type cube, I'm just repeating the same step, the same functionality in the start join. So in here, instead of taking the analytic views, where analytic views are not allowed in the start join, I'm directly taking tables and linking the actual with union and plan with union. So once you link both actual and plan, so first in the actual projection, let us select the required columns for the output in the actual projection. So let us, from HANA user CE1 IDA, let us select what are the columns that are required to the output. Click on the find icon and search for KNDNR. So this is one column I require. The second column ARTNR, which is material. The third column company code PUKRS, company code. And we have measures like VV010 and VV070. VV010 and VV070. So in here we have done for the actual, and let us do it for plan. So click on the plan and at the plan click on the find icon. Let us also select the required columns from the CE2 IDA. So KNDNR. The first column customer, the second column ARTNR, BUKRS, VV010, VV01001, VV07, 0001. So once this is done, we selected the required columns from actual and plan, and then at the union now, click on the union. Now at the union, you have both sources from actual as well as from plan data. So let us join, so let us combine both actual and plan. So let us select the required columns. Let us select columns, right click, add to target, I click and add to target. And in order to map, let us select the first column, K and DNR, and link to K and DNR, ARTNR to ARTNR, company code to company code, VV01 00012, VV010, BV07 00012, VV070. So once we have mapped both actual and plan, now the next thing is, now this union, the union over here will create the output of the union will be the fact table in the start join. So let us link union to the start join. So once you link this, so the output of the union in the start join, so this is the fact table. So what are we trying to do here? We're trying to combine two fact tables, two tables which is actual and plan, and finally in the union we're trying to combine. So are we able to combine data from more than two tables, and both of them are fact tables, and from both these fact tables we are trying to request measures. So from actual we are requesting actual gross revenue and actual sales reduction. In the plan we are requesting plan gross revenue and plan sales reduction. And in the union, now this fact table consists of data that has both actual and plan. So let us do the same thing on how we can differentiate data from both actual and plan. So we need to create a column which is an indicator, and to give constant values. So let us click on create. Let us click on create. And here in the first one, let me give the indicator. I'm just creating an additional column. So what this column will do is it will differentiate the rows that are coming from actual table and the rows that are coming from plan table. So once I give name, data type is varchar, and let's provide the length. Length is 10 and click OK. Once done, right click on the indicator, click on manage mappings, and here the source model actual, give the constant value as actual, and in the plan let us give the constant value as plan data. So once you have given both actual and plan, click OK. So here is the indicator which is differentiating both actual and plan data, and here is the final table, now which is the fact table. So this kind of schema, so when you're creating this kind of schema, these are called as snowflake schemas. Now why this is called a snowflake schema is it has more than one fact table. A single fact table is a start schema. When you have more than data requesting from more than one fact table, it is a snowflake schema. So now let us link. So in order to have more working space, let me close systems. Let me close the systems. Let us click on auto layout. So it will try to arrange, and then here let us join BUKRS with BUKRS. Let us join customer with customer, and last one material with material, ARTNR with MATNR. And So once this is done, now let us select, now in the union, if you see here, if you drag the output, so in the output we have 3 calculation views. So here you have columns. So in the columns we haven't selected any measures. So let us select VV010 and VV070. So once we select these measures, and finally click on the indicator, which is an attribute. So this is an attribute. Click on the semantics. The semantics type. This is a measure. Aggregation type is sum. 70 is a measure. And indicator is an attribute. And here when you click on shade, here you can see attribute, key attributes from 3 calculation views and attributes. So you can see all the attributes from the calculation views. So once this is done, so when you click on the free space, so once you click on any node and then click on the free space, so once you click on any free space, so here we see the column engine. The column engine is the calculation engine. If you come to the bottom, you also have execute in. So there is a different engine over here, which is SQL engine. So first what we will do here is we'll go to the column engine, which is a calculation engine. Click save and validate and click save and activate. So I'm not using the SQL engine, but here we are using the column engine as calculation engine. So right click on the calculation view and click data preview. Click on data preview. Select VV010, drag and drop into values axis. VV070, drag and drop into values axis. Let us select land 1, drag and drop into labels axis. Now if you see how much time for 17 rows to be retrieved based on country, it has taken 514 milliseconds. If you click on a table, here it shows you both measures, which is the gross revenue, and this one is the sales reduction. So here we are seeing data based on country. So if I basically go back to the calculation view and if I change the property, so how much was the previous, how much time it was taking here? 514 milliseconds. So when we execute a calculation view, when you execute a calculation view, of type start join. So calculation view of type start join executes by default, it executes on calculation engine. So the same calculation view of type start join can also be executed on the SQL engine. So when we execute this on the calculation engine, the time it has taken around 514 milliseconds. 514 milliseconds. The same calculation view when you change this engine. So here in the calculation view, we're trying to change this engine, execute in, we're changing this engine to SQL engine. So execute an SQL engine. So when you change this to SQL engine, now when you click on validate, save and validate, and when you click on save and activate, save and validate and save and activate. Once this is done, now let us see the output again. Let's try to generate the same report again. Right click on the calculation view, click data preview, click data preview. Let me take both the measures, drag and drop the measures into values axis. Now let us select land 1. Let's select where's land 1. Let's select land 1 and drag and drop into labels axis. So how much time this time it has taken? It has taken, the same result is same, but now it has taken 203 milliseconds. So previously when you execute, it has taken 514 milliseconds, but now when you execute on the SQL engine, it has taken 203 milliseconds. So in this case, so when you execute on this, calculation engine is very faster. Sorry, SQL engine is very faster when you compare with the calculation engine. Now this take 514 and here it almost take half the time than the calculation engine. Now why is that SQL engine has better performance than the calculation engine? The main reason why SQL engine has better performance is due to it has a better join determination technique than the calculation engine. The programs that execute for SQL engine have better join determination technique. So now when we see the views in HANA, so when we see there are different views. Now by now we know, by the end of the class we know, now we have views like attribute views, views like analytic views, views like calculation views of type cubes, we have calculation views of type dimensions, and then calculation views of type start joins. Now each view executes on a specific engine. Attribute views executes on an engine called join engine. Analytic views executes on an engine called OLAP engine. Calculation views of type cubes execute on an engine called calculation engine. Calculation views of type dimensions execute on engine like an SQL engine. Calculation views of type start join can be executed on the calculation engine or can be executed on the SQL engine. Now if this is an attribute view, if this is an attribute view AT, it executes internally. The representation is JE. The code is JE for a join engine. If the view like Analytic view executes, it executes on OLAP engine represented as BW. If a view like calculation view of type cube executes on CE engine, which is known as the calculation engine. View like calculation views of type dimensions executes on SQL engine. Calculation views of type start joins can be executed on calculation engine or can be executed on the SQL engine. So these are internally represented as CEQ pop. This engine represented as CEQ pop. When you execute a calculation view on the SQL engine, it has better join determination. Now why it has better join determination? We need to look into details. I mean, like all the views, we need to see the execution plan. So we need to see the execution plan of each view. Now what is join engine optimized for? Join engine is optimized for executing of complex joins. OLAP engine is optimized for mass aggregation of data. Calculation engine optimized for complex calculations. SQL engine optimized for better join determination technique. Now why is an attribute view optimized to execute only on JE engine? Why not on OLAP? In attribute view, most of the time we join master data tables to each other. So whenever we try to join master data tables to each other, it has to execute joins very optimal way, because whenever we join master data tables, it is only based on entity relationship models. Whenever you want to execute complex joins between tables, always it is optimized to execute on join engine. When attribute views are basically taken as dimensions in the analytic views, when attribute views are taken as dimensions in the analytic views, they specifically don't execute on a join engine. They skip join engine, the view gets flattened, and directly execute on the OLAP engine. In an analytic view, where it creates a start schema, in the center you have the fact table, and these are the attribute views, and the whole view is executed on the OLAP engine. It skips the join engine. When attribute view consists of calculated columns or calculated attributes, let's say an example of a calculated attribute would be concatenation of a phone number with the pin code, phone number with the extension number. So you have a phone number as one column, and the other column you have extension number. You want to concatenate. You're creating a calculated attribute. When you go back to the HANA Studio, when you double click on any of the attribute view, if you click on the data foundation, and then click on the free space, and I click on the free space, the data category over here is the dimension. When the data category is the dimension, and the column engine is a join engine. Join engines are optimized for computing complex joins. So here you have a calculated column. When you created a calculated column, these calculated columns are created in the attribute views, and when these attribute views are as the dimensions in the in the analytic view, which is a start schema, these analytic views directly go execute on the calculation engine. When an attribute view has a calculated column, when these attribute views are used as the dimensions in the analytic view, and then when these analytic views execute, the analytic views executes on the calculation engine. Again, let me repeat this again. When you execute, and so this important topic. When attribute views execute, they execute only on join engine, individual execution. When attribute views are used as the dimensions in the analytic view, they execute on the OLAP engine. When the attribute views has a calculated column or a calculated attribute, and if these attribute views are used as the dimensions in the analytic view, these executes on the calculation engine. The second point, analytic views by default executes on the OLAP engine. OLAP engine is optimized for mass aggregation of data. Mass aggregation of data means how fast it can aggregate data, how fast 15 to 30 million aggregations per second per core. So individually, when you execute an analytic view, it executes on OLAP engine, which is a BW. Internally, it is represented as BW. When analytic views have currency conversions or unit of measure conversions or calculated attributes, then the analytic views directly executes on the CE engine. So an exception over here is an analytic view consisting of calculated attributes, currency conversions, unit of measure conversions, directly executes on the CE engine. When the calculation views of type cubes execute, when a calculation views of type cube execute, if these cubes have analytic views, as a data source, analytic views executes on BW engine. After processing analytic views on the BW engine, the results are transferred from BW to CE engine. So a calculation views of type cube can communicate between BW and CE engine. So this is a sub execution and this one is the main execution. So whenever we use calculation views of type cube, the sub execution is the BW, the main execution is on the C engine. This is for calculation views of type cubes. Calculation views of type dimension execute on an SQL engine. This is for master data. Calculation views of type start join can be executed on C engine, but you know the performance. It is not faster when you compare with SQL engine, which consumes 50% less time than the calculation engine. So again, to repeat, attribute views execute on join. When they have calculated columns, they execute on CE. When attribute views are used in the analytic view, they execute on OLAP. OLAP by default executes on OLAP. When analytic views default execute OLAP. When analytic views have currency conversions or unit of measure conversions, execute on CE. Calculation views of type cubes execute on BW. This is a sub execution. Once the results are processed, then transfers to CE. When you have analytic views as data sources, calculation views of type dimension mainly for master data executes on SQL, and CV of type start join. CV of type start join limitation is it cannot use attribute views to have data sources. It can only have calculation views or tables as its data sources, and it executes on SQL engine. SQL engine is optimized for better join determination technique. That's why it consumes less time than the calculation engine. So simply to say, whenever you have a single fact table, go for analytic view. Whenever you have complex joins, go for attribute view. Whenever you have multiple fact tables, when we want to ask measures from multiple fact tables, go for calculation views of type start join. Now whenever you would like to use views, it can be attribute, analytic, calculation. When you want to join, union, projection, aggregation. When you want to create your own data foundation. When we want to create our own data foundation, then go for calculation views of type cubes. Now because calculation views of type start join cannot request data from attribute views, we recreate the same functionality in calculation views of type dimensions, and these dimensions provide master data to the calculation views of type start joins. So these are the views and these are the different engines that process these views. In the next session, what we will see is how these views internally, how they process these different engines, the internal mechanism of how they execute on these different engines that we see in the next session. So until here, if you have any questions for today's session, please ask me. So we'll see the remaining topics as and when possible. I'll show you. Okay. So whenever you have complex joins between the tables, we execute on join engine. Whenever you require faster aggregation of data, and when you require requesting measures from a single fact table, go for Analytic view. When you want to request measures from different fact tables, and if you want to have view very fast to be executed, go for a calculation view of type start join. When you want to create your own data foundation, and this data foundation can request measures from all the views, then go for calculation views of type cubes. Very simple. Complex joins, JE engine. Mass aggregation, single fact table, OLAP engine. A view that can balance between aggregation and joins is the SQL engine. SQL engine has a better join determination. It is faster based on Snowflake schema. It can request measures from both fact tables. Go for calculation view of type start join. When you want to request measures from, when you want to create data foundation and request all the views, go for calculation views of type cubes. Very simple. So I'll show you in the next session on how these views consume these different engines. Any other questions, please? So we'll see variables, input parameters. I'll show you variables in the reporting input parameters when we discuss about currency conversions. I'll show you how to write a business logic. All these things I'll show you. Just still I'm just concentrating on the engines and how they are processing this. Just I'm focusing on some fundamental stuff. So once we complete these fundamentals, then we move on to the next level. So this is about the how different engines just process. Thank you everyone.